Hello everyone, welcome to today's class. In this lecture we are going to discuss a type of differential equation that is known as homogeneous. Okay, there's a particular way to solve this kind of equation. Okay, so let's see what is first of all homogeneous. The basic definition goes like this. Suppose you have your dy by dx is some function, let's say capital F of x and y. Okay, 2xy plus 3x square plus y cube, something like that, basically in x and y both combined. Okay, now we call any function as homogeneous if, let's say, f of lambda x, if you replace x by lambda x and y with lambda y, it is equal to lambda raised to power 0, same function of x and y. If this happens, we can say the function is homogeneous. Okay, so let's verify this. Okay, this is the condition for homogeneous. All right, so this is our dy by dx, y dash is dy by dx, this is the function. So let's call this as f of x comma y. Now I'm going to find first of all whether it is homogeneous or not. Okay, so f of x lambda x, replace x by lambda x, replace y with lambda y. So if I put here, instead of x I put lambda x, instead of y I put lambda y upon lambda x. If I take lambda common from the numerator, and lambda is already there in new denominator, this is x plus y upon x, lambda lambda cancels, so effectively lambda raised to power 0, and this is the original function of xy. So therefore we can say this is homogeneous. Now if this is homogeneous, how to solve it, that's the method we have to learn. Okay, all right. Now in order to solve the homogeneous equation, you have to do one substitution. Again, learn that this is the condition of homogeneous. Y is equal to Vx. This is a substitution you need to make, and interestingly this homogeneous equation will turn to a separating variable case that we have already discussed. Okay, but if y is equal to dx, basically your dy by dx will be equal to, you differentiate this by ub, so that will be x differentiation of x is v1, then multiplied by v as it is, plus x dv by dx. Okay, in some certain scenario the question will be done by x is equal to vy also. We'll see in which scenarios, I'll explain you when the conditions come. In that scenario your dx by dy will be equal to it will be v plus y dv by dy. So basically we are replacing x by y. Okay, majoritively you will be dealing with this, very rarely you have to deal with the other one. Okay, so given that now this equation I am calling this as a homogeneous one, so there is a way to solve it. We know what is that. Do the substitution of y is equal to vx and dy by dx, or y dash is equal to v plus x dv by dx. Let's put it here. Okay, replacing dy by dx by v plus x dv by dx. Okay, and x is as it is, y is vx upon x. So what we have done is replace this question with y as vx and dy by dx as v x dv by dx. Now let's solve this. v plus x dv by dx. Now what will always happen is you take x common out of this and somehow the right side will become a simple function in v. Always that will happen. That is because of homogeneous part. Okay, take this v on the other side, so x dv by dx is equal to 1 plus v minus v also cancels. So now you have x dv by dx is equal to 1. I told you separating variable. After the substitution in homogeneous, it becomes separating variable. So take this dx on the other side, take this x also in the denominator, separate it. So dv is equal to dx by x. Integrate both sides. So what is the solution? Differentiation of v is, integration of v is, dv is v. 1 by x integration log mod x or x plus c. But our answer should be in x and y. So what was v actually? Let's look at from the question. Substitute y is equal to vx, so v is y by x. So replacing this by y by x is equal to log x plus c. Now if you want to generate equation in y only, so you get y as x log x plus cx. Okay. All right. Let's look at the next question. Always first of all generate dy by dx. dy by dx is equal to, take this on the other side and then denominator, you'll get x plus y upon x minus y. Now two things I'm going to teach here now. One is how to identify this without using lambda x lambda y, whether it is homogeneous or not. Okay. Secondly, how will you know just by looking at the equation whether it's homogeneous or linear or separating variable? Okay. So I'm going to explain you the process of solving differential equation, because when the equation comes like this, it never tells you which method you have to use. We have three methods, separating, linear and homogeneous. Okay. So first go for separating. Can you separate x and y anyhow? Can you separate? Can I take only y terms on the right and x term on the left? No. So first check separating. Separating not working. Then check whether it is linear or not. So in linear, what is the format? dy by dx plus py. Again, we need y alone. Can we get that? No, because numerator and denominator cannot be done again. And if that doesn't work, clearly it will be homogeneous. But again, you can check homogeneous orally also. One method is call this as f of x comma y, then f of lambda x lambda y. Solve it. So lambda x plus lambda y upon lambda x minus lambda y. Take lambda common from numerator and denominator, x plus y, x minus y. They should always cancel, and you should get lambda raised to power 0 f of x comma y. So yes, you can use that also, or it's what I call a method of degree. What you do is you calculate degree of each term on numerator and denominator. They should be same. Okay, so what is the, or you can look at this equation and then also can calculate. Let's look at from this directly. This term has degree 1, this term has degree 1. I'm talking about degree means the highest power. Okay, again, so while addition and subtraction of same degree, it is effectively same. So we'll say that overall degree of this term is 1. Here also degree 1, degree 1. So overall degree of these is also 1. If both have same degrees, dy term also, dx term also, it is homogeneous. Okay, we'll do this in the upcoming questions also, so you'll get comfortable with that. So anyhow, this was homogeneous. Now substitution, let y equal to vx, so dy by dx is equal to v plus x dv by dx. Now let's solve. Replace the, in this dy by dx, replace this v plus x dy by dx Then this is x plus y, x minus y, so x plus vx upon x minus vx. I told you whenever this substitution happens, the right side becomes only the function of v, so v plus x dv by dx. If you take x common, 1 plus v upon 1 minus v. This again cancels. Now take this v on the other side, x dv by dx, 1 plus v upon 1 minus v, and then subtract it from v. So LCM 1 minus v, 1 plus v minus v plus v square. That's x dv by dx. And now what you do? You do the separation of variables. So dx on the right side, x terms on the right, v terms on the left. So dv 1 minus v in the multiplication. This is 1 plus v will go in denominator. This one is dx will come in numerator, x will come in denominator. Okay. Then integrate both sides. Okay. What I've done is taken the terms of x here and v terms on the left side. Alright, so dx by dx, I think that's very simple. Log x plus c we can cite. We have to solve this one now. We can do is, I'll split this in two parts, 1 upon 1 plus v square minus integration of v upon 1 plus v square dv dv. Why I'm doing this? Because I know this is a standard result. What is that? Tan inverse v by 1. Okay, 1 upon 1 plus x square integration is tan inverse x. So this is tan inverse v minus. For this I'll use the substitution. If I take denominator as t, multiply this by 2 and 2, this is dt. Okay, so that's 1 by 2 log mod t, t is 1 plus v square, so 1 plus v square, okay, is equal to log x plus log c, or c as such. Okay. Now what can you do further? What I can do slightly, I mean this is pretty much the correct answer, but slight manipulation, very slight one, is that I can somehow combine these two logs also if I take this on the right side. Okay, and even c also, but c will go inside the log, so I don't want that. Mostly we write log if all the terms are in log. So tan inverse v is equal to, I take this on the right side, so I get log x plus 1 by 2 log 1 plus v square plus c. Okay, now max to max, what you can do is take the LCM of these two terms, because we have to combine, so we need them in a single log. So 2 log x plus log 1 plus v square is equal to plus c. This is tan inverse v right now. That's tan inverse v is equal to, take this in the power, and then you can add these two logs. So that is log x square into 1 plus v square upon 2 plus c. That's the maximum you can do. Now replace v by y by x. So tan inverse y by x, you cannot do anything about this, is equal to log x square 1 plus y square by x square plus c, and upon 2 I'll write here 1 by 2. So 1 by 2, I can solve this slightly. Log, if I take the LCM, it becomes x square plus y square plus c, tan inverse y by x. That's pretty good as an answer. Okay, so see for yourself from this to this. This is slightly better, but yes, you have to get the logs together and you should be comfortable how to add them using the properties. Okay, all right, next question. Again, we'll try to check whether this is homogeneous or not, and this time we are going to do direct. What is the degree here? 2. There are 2 terms in multiplication with 1 power. So effectively this whole term has a degree 2. Both the terms have same degree, they can be added as per the degree rule. So net power is also 2. While addition and subtraction, the power doesn't get added or subtracted. Okay, it remains the same. But point is, addition and subtractions are applicable only in the case of same degrees. So both have 2. So effective degree of this term is 2. What is the degree here? 2. This also has 2. So overall degree is, both have same, so 2. So both dx and dy terms have same degrees. We can say it's homogeneous. So I'm not checking this time. This, I know this is homogeneous. So dy by dx is equal to x square plus y square upon x square plus xy. Okay, and I'm going with the substitution. Y is equal to vx and dy by dx x plus v plus x dy by dx, v plus x dv by dx, x square plus v square x square plus x square plus x into vx. Okay, I'm replacing this. Now v plus x dy by dx. Take x square common. Denominator also has x square. I told you this function will always become a function of v only. So 1 plus v square upon 1 plus v. So x dv by dx is equal to x square cancels, 1 plus v square upon 1 plus v minus v. That becomes 1 plus v square minus 1 minus v square is x dv by dx. Okay, that's x dv by dx is 1 minus v upon 1 plus v. Now move the terms, get v on the one side. So 1 plus v, 1 minus v here. This dx will go in numerator, x will go in denominator. Integrate, and your answer. Simple enough. Is the integration sometimes that will get tricky, but you should be quick enough to check if the function given is homogeneous or not. So this is again same thing now, log x plus c. Right now let's write down log x plus c. Now how to integrate this? There is no whole square. It's just 1 plus v, 1 minus v. Okay. Now for this, what we can do is go back to your basics. The integration is tough because of the denominators, because all the rules are applicable for the numerator terms. So if I can generate 1 minus v in the numerator, that will be it. So how can I generate 1 minus v? Look at this. What I'll do is I'll write this 1 as 2 minus 1 plus v. Okay, I've written this 1 as 2 minus 1. Why? Because if I take these two terms, effectively this is minus 1 plus v, but if I take negative common, that generates 1 minus v. Okay, divide this along this negative upon 1 minus v upon let's take it common right now, 1 minus v. I'll separate this in the next step. 2 minus, take the negative common, 1 minus v, and now separate it, 1 minus v, 1 minus v, dv dv. Okay, copy the right side. 2 upon 1 minus v integration, that's simple, log. So 2 log 1 minus v. Okay, and remember the coefficient of x or coefficient of v, that's negative. So what you do is get this negative outside. Okay, so minus 2 in the denominator as such, but sign can be in the numerator as well as in denominator. This integration is done. This is only one integration of 1 is v, that's it, is equal to log x plus c. Okay, I think that's it. And again, maximum what you can do is combine the two logs if it's possible. Okay, let's try to combine them. v let's combine them. In fact, what I'll do is I'll log na vc log. If I take this as also log c, that will help. Okay, instead of this, I'll take this here first of all. So minus v is equal to log x plus 2 log 1 minus v. And now you can see, what if I write this as also log c? We'll be able to combine that. Let's write log c. We'll see what I have to do. Instead of c, I'm writing log c. I told you that constant c or log c both can be written, both are same thing. So minus v is equal to, let's combine this, take this in the power. So all terms will be in the log, 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 log. In addition, it will become multiplication. So log x into 1 minus v whole square into c is this. And what I can do is take this on the other side, log. If we take log on the other side, it becomes anti-log, which is e. So e raised to power minus v is equal to x 1 minus v square into c. Sorry. What you can do is open it. This was 1 minus v whole square, na? So let's combine it. E raised to power negative is there, na? Minus negative is there. So let it be. E raised to power minus y by x is equal to x into 1 minus y by x whole square into c. Okay. Now e raised to power minus y by x is equal to, this is x into, you'll take the LCM, so x minus y whole square upon x square, this cancels into c. So e raised to power minus y by x is equal to x minus y whole square upon x into c. I can take this x also on the other side if I don't want the numerator. So it is x into e raised to power minus y by x is equal to x minus y whole square into c. You can write this as your answer, or even take c also on the other side. Won't make much of a difference. Okay. That's it. Okay. So whether you write this as x minus y whole square is equal to x by c e raised to power minus y by x, and again 1 by c can be written as another constant k or anything you want. Okay, c1 or c2, call this c was from the starting c1 and call 1 by c1 as your new c, same thing. Okay, so I'm writing k x e raised to power minus y by x, because it's better to write constants in numerator where k is 1 by c. This could be the possible answer, or this could be the possible answer, depends how the option is given to you. Okay, but at least you have to combine the two logs. All right, next question. Now for this question, the major hint that this is homogeneous is this y by x term. If you have y by x term, you don't even have to check or anything, it will be homogeneous. Okay, it's for sure, because it is inside cos or log or any complicated function. If y by x terms are mentioned, don't have to check, definitely it is going to be homogeneous. Okay, but if you still want, go for the basics or concept of degree also. Now since it is homogeneous, so we have to do the substitution. First let's generate dy by dx is equal to, dy is here, this is on the other side, So y into this x cos y by x plus y sin y by x upon denominator x and y sin y by x minus x, no? Minus x cos y by x. The question does look weird in the starting, but do the substitution. Let y is equal to vx and dy by dx equal to v plus x dv by dx. So y is vx actually, vx this is x cos vx by x, so only v, minus y is again vx and this will become sin v. Denominator will become x vx sin v minus x cos v. Okay, now take x common from the numerator and denominator, you get v x square upon x square. This is cos v minus v sin v. This is v sin v minus cos v. Okay, x square also cancels. That was supposed to happen. I told you that the right side becomes only the function of v. Now x dv by dx is equal to v into cos v minus v sin v upon v sin v minus cos v with subtraction of v. So if we take the LCM, this will be multiplied by v sin v minus cos v. Yeah. So now you can take v common if you want. If you don't want to multiply this by v and then solve, so you can take v common. Otherwise, you can go for the multiplication also. So cos v minus v sin v minus v sin v minus cos plus cos v. Okay. V sin v, v sin v. V sin v minus cos v, v sin v minus cos v, cos v minus, this was not minus, this was plus, this was plus, this was plus, this was plus. Something should be cancelled now. So yes, finally something got cancelled. I was expecting something to be cancelled, like there was symmetry in the question, so something is supposed to be cancelling. V sin v minus cos v. Okay, so cos v plus cos v is 2 cos v, so 2v cos v upon v sin v minus cos v, and this is x dv by dx. So now all you have to do is change the variables, x on one side, v on other side, separating variable. So dv into v sin v minus cos v upon 2v cos v is equal to dx by x. Now integrate. So it's not the right side that's the problem, it's the left side that is going to be difficult slightly. So if we do 2v cos v is a single denominator, so let's split it. So 2v sin v upon 2v, sorry, v sin v upon 2v cos v minus cos v upon 2v cos v I think after splitting it becomes very obvious. This v cancels, cos v cos v. It's my bad habit of writing x. Cos v cancels. So this is nothing but 1 by 2 tan v integration, and this is integration of only, what is this, dv, no? 1 by 2v. So 1 by 2 I can take effectively common from the both expressions. So tan v minus 1 by v integration dv. Okay, is equal to dx by x integration. I think it's done now. It's already in format. Log tan integration, tan x integration is minus log cos x or log sec x. Okay. So this is 1 by 2 log, I'll write sec x minus this is log x. Okay. Sorry, log v. 1 by x is integration log x, 1 by v is log v. This was also v. This is x. Dx by x is log x. And now you see a lot of logs are going on. So log x plus log c. Okay. All right. Now combine them. Let's combine them. Log sec v upon v is equal to, this is, let's take this 2 also in the other side. This becomes 2 log cx. Okay, so this becomes log sec v upon v is, take this 2 in the power, this is log c square x square. Again, let's write this as c1, and we'll call c1 square as another constant c. Okay, there's no point in writing the constant square as such. So what is now the point of writing both the logs is we can cancel the log from the both sides. Okay, and this becomes only sec v upon v is equal to, this is another constant c x square. Okay, so sec v, so that's sec y by x, take v on the other side, so that's y by x multiplied by c x square. So x square x cancel, so sec y by x is equal to c xy. That's the answer, that's the solution. Okay, you can generate this in cos also if you want, won't make much of a difference. Okay, sec is 1 by cos, you can do that. All right, so the moment you see y by x in the question, you should know it's a homogeneous question where you have to do is the substitution y equal to vx. Okay, and now the other part of the question. All right, last one. If you see x by y term, again it is going to be homogeneous, and this time you are going to use the substitution x is equal to vy. So dx by dy, first of all you need to generate dx by dy rather than dy by dx, is equal to v plus x y dv by dy. Let's solve this. Let's generate dx by dy first of all. So dx, this is, let's erase it, not read it like this, 1 plus e raised to power x by y is equal to minus e raised to power x by y, 1 minus x by y dy, and now you generate dx by dy. It is minus e raised to power x by y, 1 minus x by y upon 1 plus e raised to power x by y. Let's do the substitution now. dx by dy is v plus y dv by dy is equal to e raised to power x by y will be v, So directly e raised to power v, 1 minus v upon 1 plus e raised to power v. Take this v on the other side, y dv by dy. Copy this, minus v. So take the LCM and now solve. Multiply it and solve. E raised to power v minus v e raised to power v minus v minus e v e raised to power v. Y dv by dy. Let's solve this. 1 plus e raised to power v. Something should cancel this one. So what is left is e raised to power v minus v. That is y dv by dy. So let's generate v terms on one side and dy on the other. After this, always you have to do separating the variable. Okay. So dy by y on the right side, dv into 1 plus e raised to power v upon e raised to power v minus v. Okay. This integration. Okay. This is minus now. What we can do is substitution can we do? We can do substitution. E raised to power v can be. If we take the denominator as t, the only problem is e raised to power v is there, minus 1 is there. Is the minus correct? One minus. There was also a negative going on. We forgot that. Forgot that. We forgot that. X by minus 1, v minus 1. Negative was already there. Got stuck slightly. Log. Okay. Usually the mistakes sometime happens with a very silly positive negative signs, and that was this negative that I missed. Okay. Because of that negative, this term substitution was not working. Let me rectify. So this was the mistake. Because of that negative, this whole negative was missing. It was creating a problem. Forget about this bracket. There was a negative with this term. Okay. Now open it. Okay. What rectification will be there? Minus e raised to power v plus v e raised to power v minus v minus. Oh, I cancelled it also by mistake. Now it is there. Negative. Both terms are negative coming. So I think now the substitution will work. Now it's okay. You take the negative common, now it's done. This is 1 plus e raised to power v, negative is common outside, that's e raised to power v plus v dv, and now the substitution works, dy by y. Okay. Take this denominator as your t, take this whole thing, e raised to power v differentiation is e raised to power v differentiation is 1, dv along with it, that becomes dt. So this is minus log t, means log e raised to power v plus v is again this you want to take this as log y plus constant, you will take log c. Okay. Now take all the logs on one side and combine them, so you will get 0 is equal to log e raised to power v plus v into y into c. Okay, everything will be multiplied, log a plus log b plus log c, multiplication. So 0 is equal to let's replace this log also. If we take log on the other side, it becomes anti-log, that's e. Okay, so this becomes e raised to power 0 is equal to e raised to power v plus v into y into c. Anything raised to power 0 is 1, so 1 is equal to e raised to power v is e raised to power v was x by y in this, plus x by y into y c. So 1 is equal to e raised to power, if we take the LCM also, x e raised to power x by y plus x upon y into yc, and these two y cancels. Okay, so that's a simple equation. Take the c also on the other side, so 1 by c is equal to x e raised to power y by x by y plus x. Okay, you can take x also as common. Sorry, bad habit. This was y. After taking LCM, it was supposed to be y. So y e raised to power x by y plus x is equal to 1 by c, and you can call this 1 by c as another constant k or c1, c2, or call it as a new c also. So this is y e raised to power x by y plus x. Okay. All right. That's your answer. Done. Okay, one question. MCQ sort. You have to find which is a homogeneous equation or not, and again I'm going to use the method of degree. Okay, degree 1, degree 1, degree no, not 1, 0. So when 1, 1 and 0, you cannot combine them together. So effectively this term has no effective degree, so this cannot be homogeneous. Okay, same problem here also. Suppose although we have decided this is not homogeneous, because if one part is not having a equivalent degree, we cannot have a homogeneous equation. Again, degree 1, degree 1, degree 0, again you cannot combine 1, 1 and 0 degrees. Whereas this term has degree 2, x and y now multiply power 1, so effective power 2. This has power degree 3, and both have equivalent, so they can be combined together. So you have a degree 3. Here the degree is 2, here's the degree is 3. So degree of dx term and degree of dy term, they are not equal, so not homogeneous. Okay. Degree 3, degree 2. Okay, 3, this is 2. So cannot be combined. The moment they cannot be combined, this is not homogeneous. So by default the last one is homogeneous, but still check it. Degree 2. Degree 2, 2, 1, 1, 2. Multiply, you add them power wise. 2. So net degree is also 2. Both dx and dy term have same power. So yes, this is the correct answer. Okay. So degree of dx term should be equal to degree of dy term. So you can check this orally. You don't have to put you don't have to generate dy by dx and then calculate by replacing lambda x and lambda y. Okay, that's a lengthy process. So for MCQ, don't use that anyway. All right, that's it for this homogeneous. Okay, the topic is ended. See you in the next class. Good day, everyone. Bye.